Okay, this is a video to help with series circuits, but here's some general information to start with. When we go into the AC, things become vectors. So we have a real axis, which will represent our resistance and will always be along the positive real axis. And then we can have something called inductive reactance, which will always be along our positive imaginary, or what you probably remember as your positive y-axis. It's actually an imaginary axis. It's actually a number. This is two sides of a right triangle, and I didn't put the little square in the corner. The hypotenuse is the magnitude, and then there's the angle that the hypotenuse makes with the positive real axis, and that is the other part of the polar form. So when I talk about rectangular form, I'm talking about the real plus the imaginary, or the two sides of the right triangle, or I can ask for it in polar, which would be magnitude and angle. There is a formula for getting the impedance of something, and it basically is finding the hypotenuse. It takes the R and the XL or the XC, and it comes up with the Z, but it doesn't have the angle. Okay, so what I'm trying to promote is do it completely. You can use that formula certainly to find the magnitude, but you also need to know the formula to find the angle as well. Now, XL is always along the positive imaginary, and XC or ZC is always along the negative imaginary. So if I have a resistor in series with a capacitor, then I can just add them up, and I know that my magnitude will be whatever the hypotenuse is, but my angle will be negative with respect to the real axis, or the positive real axis. If I have an R and an XL and I add them up, then my angle will be positive. Now the circuit I'm going to do is a RLC. So I've got some XL and I've got some XC, and since they are on the same axis, they can be added and subtracted. So we don't know which way the triangle goes until we figure out what specifically we got for XL and XC. Okay? So now what I'm going to do is I'm going to go over here to LT Spice, and I'm going to show you my circuit. I've got 3K of resistance. I've got 3.98, and that would be Henry's of inductance, and I've got 99.5 nanofarads. Nano is 10 to the minus 9th capacitance. I've got a 10 volt source, and I'm going to analyze this at 200. So you could build this circuit. LT Spice would analyze it all day. It'll take care of all the background stuff for you, but I'm trying to show you what the background stuff is. So I've made a spreadsheet also, and for those of you in my class, I'll make the spreadsheet available, where if I know my L and I know my frequency, which I do, it will calculate my XL. So I think my L is 3.98, and so my XL comes out to be 5001. This is the formula that I used. Now on the spreadsheet, the yellow boxes contain formulas, so don't ever type anything into a yellow box because they're formulas. Always type beside it. Okay, if you do that. So my XL is about 5,000, and my XC I don't know yet, but I knew I had 99.5, and XL will let you do the E minus 9 for the scientific notation. And so what you see is I've got about 5,000 ohms of inductive reactance and 8,000 ohms of capacitive reactance. So my circuit is net capacitive. Okay? So the impedance for the circuit in terms of real numbers are 3,000 for the resistor, and my imaginary will be the difference between 79.97, which we're going to round to 8,000, and 5,001, which we're going to round to 5,000. And since it's capacitive, it's going to wind up being minus 3,000. So minus 3,000. And what you see is that I have a triangle, 3,000 real, 3,000 imaginary, and then the magnitude of the hypotenuse is this value, and the angle is minus 45. Okay? If somebody gives you a polar and you want to know the real, then you got to put in the hypotenuse and the angle, and the yellow will go the other way. It'll go from one side to the other. Okay? So that is what we've got here in terms of impedance for our circuit, and I sort of wanted y'all to see how they combine. Series circuits in AC are just like DC circuits with resistances. You just add them up. Now your resistance, you will add them separately with each other, and your capacitance and your inductance, inductive reactance, capacitive reactance, you would add those, but always your XC is minus, where's my image? There we go. So my XC will always be negative, my XL will always be positive, whatever the difference is. So in the case that I illustrated, I have about 3,000 ohms and about 3,000 ohms of capacitance net. So my triangle would look like this for the impedance. Ohm's law would still apply. So you take your voltage and divide by your impedance, and you will get your current, which will also have an angle. And if you use voltage as a reference angle of 0, then the impedance angle, this negative impedance angle we got, will become positive with the current. And you'll see that a little more clearer next semester. But I hope this helps in terms of real and imaginary and going back and forth between them. And of course you want to see what SPICE gets us. Oh, well, let's do that. We got that. So my impedance is 3,000 minus 3,000i. So I'm going to go in and say, okay, I've got, is that 10 volts? Yes. So I'm going to say 10 and divided by 3,000 minus 3,000 times percent I. That's how we do imaginary numbers in Scilab. And I get a current flowing in my circuit of that, which is about 1.6 milli plus 1.6 I milli, or 1.7 I milli amps. If I want to know what my meter will read, I'll just do the absolute value of the answer, and it's going to read about 2.36 milliamps. So keep those in mind. And I go over here and I do my run. And what do you see about the current through all those devices? It's about 2.36 milliamps. It's got a phase angle of 135, which is really essentially a 45-degree angle. It's one of those. But you see that I got voltages with angles. Everything in SPICE comes out in polar. Magnitude, phase. Phase is angle. And then if you do it in Scilab, it comes out in rectangular. So it's very important to be able to convert. And you now have a tool. Anyway, I hope this helps. I hope this helps going forward. Thanks for watching.